Okay, let's sketch a function for the following scenario. F prime of x is equal to 1 when x is greater than negative 2, and f prime of x is equal to negative 1 when x is less than negative 2, and f of negative 2 is negative 4. Okay, so I'm going to start with the derivative function. I'm going to use f prime of x in blue to represent my derivative function. We can notice here that the derivative function is going to be 1 when x is greater than negative 2. This is negative 2, it's going to be equal to 1, so I'm going to use this point. Right, and we can see that the derivative function is going to go out this way. Okay, I'm just going to keep going. Okay, we also know that the derivative function is negative 1 when x is less than negative 2. Okay, so if it's less than negative 2, we should see that the derivative function would go out this way. Okay, now using the derivative function, I want to find my actual function. So for my actual function, I'm just going to do it in orange. Okay, so we're going to use f of x in orange. And we know that the point here is negative 2 and negative 4. So we have negative 2 and negative 4. It's going to be somewhere here. Okay. And we can understand that the point, so below negative 2, the derivative was basically negative 1. So we want a negatively sloping line, right? So if we want a negatively sloping line, what that's going to look like, and we want a slope of 1, right? So I'm just going to make a slope of 1. And so this is like a potential sketch. Okay, so it would kind of look like that. Okay, so that's a potentially sloping line. Don't mind the sketch too much. And then the other scenario here is from the x is greater than negative 2, we have a positively sloping line of positive 1, right? So in this case, we're going to see something like that looks like this. Okay, so positively sloping line and vice versa. So you can kind of extend these guys, right, infinitely. Okay, and you can actually notice that at this point, at x is equal to negative 2, we can have something, this is something called a cusp. So a cusp is basically a sharp-edged vertex. So it's a sharp vertex. And the derivative of a cusp, right? We write derivative of a cusp doesn't exist. So that's why it appears as, in the derivative function, it actually appears as a whole, as a discontinuity, right? So it appears as a discontinuity. So the derivative of a cusp doesn't exist. And this is your original function f of x, and in blue, that's your derivative function.